Hey everyone, welcome back to another video with the Chemistry Sisters. Today's topic is organic chemistry, and we will be discussing the addition reaction between cis-2-methyl-butene and 1 mole of water. To begin, cis-2-methyl-butene is an alkene reacting with water. Therefore, the general word equation for this reaction is alkene plus water with the catalyst sulfuric acid at 100 degrees Celsius, which will produce an alcohol. We will draw the structural diagram to determine the formation of the product. The first reactant is cis-2-methyl-butene. The but in the name specifies that there are 4 carbons in the parent chain. Let's start off by drawing 4 consecutive carbon atoms linked by single bonds. The 2-ene indicates the presence of a double bond, specifically at carbon number 2. We draw another bond between carbon number 2 and carbon number 3 to make a double bond. The 2-methyl implies that there is a methyl group on carbon number 2, and remember, a methyl group only consists of 1 carbon. Cis or trans dictates the placement of groups around the double bond. Cis formation means groups are placed on the same side of the double bond. The final step is to draw the insignificant hydrogens. The insignificant hydrogen on carbon number 3 will be placed on the same side as the methyl group to show a cis formation. So a cis formation could look like this, or this. Moving on, the next reactant is water. The structural diagram of water is drawn with oxygen at the top connected to 2 hydrogens. With the VSEPR theory, we know water has a trigonal planar shape. The arrow is used to show the formation of the products. In this reaction, the catalyst sulfuric acid at 100 degrees Celsius will be used. Finally, to determine the product, first the bond in the water breaks, separating the H and the OH. Next, the double bond is broken. Since this is an addition reaction, the remaining H and OH groups are added to the alkane on carbon number 2 and carbon number 3. But where is each one added? Let's take a look at a simple analogy to understand this. In the tale of the Wizard of Oz, after surviving a tornado, Dorothy found herself at a crossroad. She came across 2 identical paths, not knowing which one to choose. Dorothy could take one path, leading her to the arms of the wicked witches, or she could take the other and find the great wizard to return home. Similarly, as the bond breaks in water, there are 2 possibilities for the placement of hydrogen. Dorothy made it to the wizard, but how did she determine which path to take? Luckily, Glinda, the good witch, was there to help. She told her to follow the yellow brick road. Markovnikov is the good wizard in organic chemistry. He developed a rule to determine the placement of the hydrogen when there are 2 possibilities. According to Markovnikov, the hydrogen is added to the carbon with more hydrogens. In other words, the rich get richer. With this information, we can accurately determine the product. As we analyze this reactant, we can focus on the 2 carbons of interest. Carbon number 2 has no insignificant hydrogens due to the methyl group, and carbon number 3 has 1 insignificant hydrogen, and 1 is greater than none. So therefore, the hydrogen is added to carbon number 3 and the OH group is added to carbon number 2. So this is the structural diagram of the product. So, does Markovnikov's rule affect the formation of your products? The answer is yes. Without the application of Markovnikov's rule, the placement of the OH group on carbon number 2 is not definitive, as it could be placed on carbon number 2 or carbon number 3. Markovnikov's rule dictates the placement of the hydrogen on carbon number 3. Therefore, the alcohol must be placed on carbon number 2 to form a 2-methyl-butan-2-ol. So the final reaction looks like this. Cis-2-methyl-butene plus water with the catalyst sulfuric acid at 100 degrees Celsius forms 2-methyl-butan-2-ol. So hopefully this video helped, and don't forget to subscribe. We'll see you next time.